Hello everyone and welcome back. So far in this course, we have learned what OpenClaw is, how it works, and we deployed it on Microsoft Azure, Google Cloud Platform, as well as on Amazon Web Services. Now it's finally time to start using OpenClaw. In this lesson, we will explore the OpenClaw web interface, understand the purpose of each major section, and learn a few useful CLI commands that will help you manage your OpenClaw environment. Apart from that, we will also connect to Telegram channel and we will see what are the steps involved in that. By the end of this video, you will have a complete end-to-end workflow from creating an agent to chatting with it. Okay. So before we start clicking through the interface, let's first understand how all of these components work together. So everything in OpenClaw revolves around this one central idea, an agent. An agent is powered by an AI model, can use tools and skills to complete tasks, communicates through one or more channels, and every interaction is stored on as a session. So OpenClaw's capabilities are extended through tools, skills, plugins, channels, and automation hooks. Once you understand this relationship, the rest of the interface becomes much easier to navigate. So imagine you have created an amazing AI assistant. How do you actually talk to it? That's where channels come in. Channels are the communication layer between your user and OpenClaw. OpenClaw supports multiple messaging and communication platforms through its channel architecture. So example includes Telegram, Slack, Discord, WhatsApp, web chat, and there are many more. You can check the official documentation for the list of all supported channels. Without a channel, nobody can communicate with your agent. The channel does not process AI requests. Its job is only to deliver messages to the gateway. OpenClaw is designed around a single gateway that serves multiple configured channels simultaneously. So now let's go to our OpenClaw web interface, and here let's search for channel. Here we have various supported channels available to configure. For example, let's take Telegram. Imagine you have created a Telegram bot and a user sends it the message. Summarize today's GitHub pull request. The message is first received by Telegram. At this point, Telegram has no idea how to answer the question. It simply forwards the message to OpenClaw through the configured Telegram channel. So the flow looks like user send a message via Telegram and Telegram send forward that message to OpenClaw gateway. That's all the Telegram channel does. We will configure Telegram in just a few minutes. At this point, you might notice something interesting. OpenClaw already provides a built-in web interface, right? Which is this web interface, and you can chat with your agents directly from here, right? So if that's possible, why do we need channels? The OpenClaw web interface is primarily designed for administrators, developers, and testing. It's the ideal place to create and configure agents, test prompts and workflows, monitor various things, debug issues, and manage your OpenClaw environments. It's essentially your control center for managing the platform. However, in a real world deployment, you already use applications like Telegram, Slack, Discord, Microsoft Teams, or WhatsApp every day, right? So instead of asking, instead of using the web interface, you can simply allow OpenClaw to bring your AI agent to the platforms you use on daily basis. Okay, so instead of log into your virtual machine or your local system where you configured your OpenClaw, you can simply use your day-to-day applications to talk to your OpenClaw environment, OpenClaw agent. Okay, so for example, your engineer team, you can give access to them, and the engineer team can interact with an AI assistant directly from Slack, right? Employees can request information from Microsoft Teams, or you can embed an AI assistant into your own website using a web chat channel, right? This makes the experience much more natural for users while administrators continue managing everything from the OpenClaw web interface. Now, let's talk about gateway. So think of the gateway as the brain of entire platform. Everything passes through the gateway. It receives messages, it authenticates user, it determines which agent should handle the request, It manages routing, it maintains sessions, it returns response back to the correct channel. So without the gateway, none of other components can communicate. The official documentation describes the gateway as the single source of truth for routing, sessions, and channel connections. Now you should understand why gateway exists. Next we have sessions. So every conversation has become a session. Think of session exactly like a chat history. Every message, every response, every tool execution is stored inside the session. This allows OpenClaw to preserve conversation context over time as part of its agent runtime. Okay, now let's move to agent and get some detailed idea about agent here. Okay, so actually, here is where the real work begins. Agents are the heart of OpenClaw. Every assistant you build, whether it's a customer support, coding assistant, HR assistant, research assistant, is simply an agent with different instructions, models, tools, and permissions. Each agent has its own workspace and session stored managed by OpenClaw runtime. So think of an agent as a team member with a specific role. One agent might answer customer questions, another might summarize documents, while another could automate internal IT tasks. Here you will see a list of all existing agents, their current status and model they are using, and the actions available to manage them. So right now we only have the main agent, which comes by default on this OpenClaw setup. So it's showing only this. The agent is intelligent, but the intelligence comes from the configured model. So OpenCloud supports multiple providers such as local Olama models and cloud providers like OpenAI or Anthropic. The agent uses whichever model is assigned to it. Think of it this way. Agent is an employee and the model you configured for this agent is its brain. Let's look at something that makes OpenClaw quite powerful behind the scenes, the agent workspace. Okay, so each agent uses a single workspace directory as its own working directory for tools and context. Okay, so think of workspace as the agent's home directory. This is where it stores context, memory, instructions, and other files that help shape its behavior. When a new session starts, OpenClaw automatically reads a set of special files from the workspace and injects their content into the agent's context. This gives the agent important information about its identity, personality, user preferences, and operating instructions before it begins. So let's check these files here. I'm on this virtual machine, and here if we go to /home/ubuntu /openclaw, then here you can see all these files available, and here we have this workspace directory. Now navigate to this workspace directory. Here you can see all these files used by agent. If we check agents.md, this file contains the agent's operating instructions and long-term guidance. Think of it as the agent's playbook. For example, how it should approach tasks, rules it should follow, preferred workflows, important operational notes, etc. Okay, if you want the agent to consistently behave in a certain way, this is one of the primary files that influences that behavior. Okay. Next, let's check soul.md file. So this file defines the agent's personality. For example, professional, friendly, technical, formal, creative. How should the agent behave? You can think of this as the agent's character and communication style. Next, we have identity.md file. This file defines who the agent is. It typically contains agent name, its identity, etc. So you can check this file here. Next we have user.md file. This file contains information about the user. For example, preferred name, communication preferences, background information, or custom instructions. This allows the agent to personalize responses over time. After that, we have this tools.md file. This file contains notes and conventions related to tools. For example, how certain tools should be used, internal tool guidelines, recommended workflows. This helps the agent understand how to work with its available tools more effectively. Then we have memory.md file, but this is optional but extremely useful. Some of the time you will not find this file available. It acts as an agent's long-term memory. You might store important decisions, project summaries, user preferences, frequently referenced information. So instead of repeating the same context in every conversation, the agent can reference this memory when needed. And lastly, this bootstrap.md file. This is a special file used only during the first time setup of a brand new workspace. OpenClaw uses it to guide the initial onboarding and identity creation process. Okay. So apart from this bootstrapping files, we also have this openclaw.json file in the home directory. So if we open this file, you can see all the configurations which we did for our OpenClaw is available here. So this is a very important file and you can refer it for your OpenClaw environment. So this is one of the reason OpenClaw feels much more powerful than a simple chatbot. When a user sends a message, the agent is not responding from a blank slate. It has access to these files. Okay. If you configure nothing, OpenClaw runs one agent, which is the main agent here. Okay. So that's all about agent. Now let's move on to tools here. Now this becomes very easy. Say without tools, the agent can only generate text. With tools, the agent can actually perform work. For example, search Google, read files, execute commands, generate images, access APIs. Suppose you are deciding what is this agent allowed to do. The documentation groups these capabilities as scalable tools that agents invoke to perform actions beyond text generation. Okay, so in this group we also have skills. So instructions tell an agent how to behave, right? But skills are markdown instructions files that teach the agent how and when to use tools. Okay, for example, invoice processing, meeting summarization, GitHub review. Instead of rewriting those workflows for every new agent, you create a skill once, then reuse it. The official documentation describes skills as reusable workflows or operating procedures that can be attached to agents. All right. And after that, we have hooks. So, say sometimes you don't want to wait for a user message or you want something to happen automatically, right? For example, a deployment finishes, you want to notify Slack, or a scheduled job completed, you want to generate a report. So hooks enable OpenClaw to respond automatically to events as part of its automation capabilities. So there is lots of information available on OpenClaw's official documentation. You can refer to this website anytime you want to search for something. Okay. Lastly, I want to cover some basic OpenClaw CLI commands to manage your OpenClaw work environment. So let's go to our terminal and run OpenClaw Doctor. OpenClaw Doctor is used for health checks and quick fixes for the gateway, channels, plugins, skills, etc. And use it whenever something is not behaving as expected and you want one command to explain what is wrong. Okay, in that case, you just run OpenClaw Doctor from the terminal and you will get the issue or report in the output. Okay. Now OpenClaw gateway status. Second command we have here is OpenClaw gateway status. This shows the gateway service. Okay, launched is systemd. So plus an optional connectivity auth probe. Okay, so if there is any issue, it will give you the output here accordingly. Now, then we have OpenClaw logs ---- follow. So this tail gateway file logs. Okay, and if you want to check the OpenClaw version, you can run OpenClaw ---- version. Now, for instructions on switching LLM providers or models, please refer to the previous deployment videos in this course where we covered those commands in detail. Okay. Now that we understand how OpenClaw processes a request internally, let's connect it to a real communication channel. For this example, we will use Telegram, one of the most popular messaging platforms supported by OpenClaw. So for that, open Telegram. I have this fresh setup done on my desktop. So navigate to apps and search for BotFather. BotFather is Telegram's official bot used to create and manage other bots. Okay, so start a conversation with BotFather and run /new bot command. Or simply you can use BotFather's apps, which I'm going to use here for graphical user interface. So instead of /new bot command, I can directly provide the details here. Provide the details. Remember, the username must end with the bot. Okay, so you may get username already exist messages here. Try to adjust it until you get the successful message. Okay, so once both values are accepted, BotFather generates a bot token, right? So this token is very important because it allows OpenClaw to securely communicate with your Telegram bot. So copy this token and keep it handy. We will use it in the next step. Now let's switch back to OpenClaw terminal. OpenClaw provides an interactive command that makes configuration channels straightforward. So just run OpenClaw channels add command here. Here you will see the list of supported communication channel. Select Telegram. Follow on-screen instructions here. OpenClaw asks for the bot token. Simply paste the token that BotFather generated. In terminal, you can just right click to paste the token. Now again, it will take you to the select the channel. So in case if you want to configure any other channel, you can select that. But in our case, we just scroll down and select finish. So the next prompt asks for DM policies. Configure it with your pairing option. Do the remaining setup for routing and agent selection, which agent should handle incoming Telegram messages. Okay, so in our case, we only have one agent, so we will use the default one that is already configured. Once it is completed, go back to Telegram, search for the bot we just created. So in my case, my bot name is this here. So click start at the bottom, or you can type /start. Okay, so it will give you pairing code as well as pairing command, right? So simply copy the command and paste it in the OpenClaw SSH terminal. You will get successful approved message here, and here is the sender ID. You can check this. Okay, simply I entered hi here. You can see bot is typing. The message is immediately received by Telegram. Telegram forwards it to the configured OpenClaw channel. The gateway receives the request, routes it to the appropriate session and agent. Here you can see new session created with this same Telegram sender ID. Okay, so the agent generates a response and finally the reply is delivered back to Telegram. This is exactly the request lifecycle we discussed earlier in this video, only now you are seeing it in action. So that's it for this video. In this video, we explored the OpenClaw web interface and gained a solid understanding of how its core components work together. We also covered some essential OpenClaw CLI commands and walked through the complete process of configuring a Telegram channel. In the next video, we will put everything into action by interacting with our OpenClaw agent through Telegram. We will assign it a real-world task and follow the complete workflow to see how the agent processes requests and delivers intelligent responses. So thanks for watching.